forward. Okay, so as we get started, let me go ahead and show you how I created this. We'll just step through it and then we'll actually do one live also to show you how simple this process is. So initially what I did was I created a sketch, and that sketch was a sketch of a circle. That's it. And then I took and extruded the circle into a cylinder. And I could have just picked under create and created a cylinder. That would work also. Just like in Inventor, we also have the core building block products that we can work with. And so after the cylinder, you use a tool called Coil. And this Coil tool allows us to create both a coil, like a spring, or use it to remove material to create an auger. And as we showed you in Inventor on Monday, the auger process works pretty well. Now this one isn't 100% exact the way that I would like it, but it's close. But the interesting thing is that the auger is created from within the coil command. I don't have to create any additional cutting tools like we did with Inventor. We had to actually take a cutting tool and then cut the coil or use the coil as the tool for cutting. Well, here the feature has the cutting tool already built in. And so if we edit this feature, we can see that we start with the revolution in height. So if you remember back to Inventor, we had the same three options. Pitch between each of, and pitch is the distance from the one point to the next point. That's like the standing waveform. So the distance between the waves is the pitch. We can do number of revolutions in height, revolutions in pitch, and height and pitch. Or we can just create it as a spiral, which in this case, when you do that, it just creates kind of a cool spiral looking thing. But we were actually working with the revolution in height. And so my idea was to create, you know, the auger component. And so there's different tools. Like for example, the first thing that you'd want to do is pick what your cutting tool looks like: triangular, circular, square. Is it going to be triangular external? And if you go triangular external, gives it a different look. And so if I choose OK, you can see that the triangular external gives it a totally different capability. Would this work? Yeah, it's actually still attached on the bottom, so that center rod would still work. But would it move enough candy for you? Probably not. But it gives the ability to have a variety of different looks. If we did square, okay, it's just a square component, and if we did circular, it's not going to do anything based on the numbers that I have. So we did triangular internal, where cut the internal. Now I said that we're going to do, on our design, we did 5 revolutions. Well, we can change that. Okay, if we go above a specific number and it intersects itself, it's going to fail and say that it can't do that. So 5 was my maximum number of revolutions. The diameter is the diameter of the cut. So if I go 1.0, you can see how I can change the look on how this works. If I go 2.0, it goes too big, it fails. 1.25, okay, excuse me, 1.25. And you can change, notice that I lose some of the characteristics. So what I'm changing is the diameter of the actual cut. And so what I can do is, instead of going larger, I can also go smaller. So 0.75, And you can see that that changes the way that it looks. 0.50, too little. 0.65, again, error message. 0.7, coil radius is too small. 0.75, that's what we have currently. 0.80, and you can see how it widens out the middle as the coil gets slightly larger. And I believe my cylinder, and we can check the sketch. I don't know if let me go ahead and finish this at 0.8. Go back to the sketch and see if I provided a distance. I did, 1 inch. So the maximum diameter that I'm working with is 1 inch. And so that means I have about a 1/2 inch radius on each side that I'm working with. Let me finish the sketch, and we can go back and continue to edit the coil. The height, 2.30, so 2 inches was the height of my cylinder. And so if we make it smaller, we'll say 1.5, it won't cut all the way through. If I go 2.0, still not large enough. 2.5, and you can see how it cuts. And if we go 3.0, it continues to extend the height of the coil. And so it changes the angle then of the coil, plus it then changes the pitch distance. Remember, we still only have 5 coils, but the taller that I make the height, the distance of the pitch changes. And that also means that I could change potentially the diameter. And again, that internal diameter will provide a thicker middle as opposed to a thinner middle. And so you can see how that works. And if I go 1.0, that's to the outer part of the cylinder, but you can see how thick the internal cylinder happens to be. And the section size is the distance. Let's see here. Let's choose OK. You can see that the section size is the distance on this edge. And so if I change that section size, I can make this edge. You can see that it's trimming off a portion of this. So let's see here. If height is 4, let's go height of 2. Whoops. And you can see that that is smaller. 2.75. What I'm doing is I'm making this side a little bit smaller. And so the section size allows us the, let's see here, if I do 1.0, what does that do? That fails. So that section size there. Now if I do it on center, and if I do it on the outside or the inside, that will also change the structure of the triangle. So again, you don't get the choice of creating the cutting tool here. What you do get is the choice of working with all the variables associated with the coil creation. I did not play with the angle. We can test the angle here. So 5 degrees. See what this actually creates. Yeah, interesting. So again, Again, you can adjust that. So the process is, and if you wanted to create an actual coil, you could do that too through the circular tool to create the springs. So again, concept is that you don't get a choice of the cutting tool. However, you get the choice of being able to edit it. In that part of the editing, it's a little bit clunkier because of the controls than Inventor, but you do have basically the same type of structure that you can work with. Let me go with 4 revolutions, and you can see how it changes the distances. Oh, that failed. Interesting. But you can see how it can change the coil component. So again, experiment with it if you're going to utilize the coil. Again, our goal is to move the candy, so you've got some flexibility with that with the design itself. All right, so to actually create this from scratch, what I did was initially just created a sketch, and then I created a circle. Finished the circle sketch, and then use the coil tool based on that circle. Now, I have not used it with a rectangle, so that would be interesting to see what it would do with the rectangle. And it wants me to place the center point and the diameter of the coil. So you can see what it did was currently the section size is 0.364. Let's see, if I go 0.25, you can see that the section size is the diameter of the coil itself. So again, I can change the diameter of the spring coil. The revolutions are 3. We can say we want 4 revolutions. Again, each time you do that, the pitch distance changes between the coil locations.
So are we making a candy machine or are we making a vending machine?
Well,
just kidding.
If you're, if you think about it, if you're going to distribute the Werthers in the package, then you might have to stick the. Let me cancel. Oh, what happened? Bummer. You might have to stick each of the. Oh, that was bad. Let me undo that. Stick each of the Werther packages like a vending machine. If you think about that, there we go. So each package of the Werther original might go in between each of the coil slots, like a vending machine currently is designed. And so that does make a difference, and it gives you the ability to work with it. Now, let's see here if we do on the inside or on the outside. So that's interesting. If I do triangular external, so instead of having a round coil, you could have a triangular pointed coil. So instead of having a rounded outer edge, you can have a triangular external. If we do triangular internal, that's the internal part of the coil. And if I choose let's see here. And if I subtract the coil from a cylinder, then that's where I can get the auger component from with that. So we can choose rotation. It's based on plane. If I do from on center, okay, that's okay there. Operation is new body. So realistically, if you wanted to use the coil as a cutting tool, you could create a coil like this, move it and position it onto a cylinder, and then use that as the cutting tool to cut into the cylinder itself, which is another way to do that particular option. So you can actually work on that'd be a little bit thick, and diameter is 1.4, height is 1.5. We could have to go with like 2. So if you did this, notice that this would be your cutting tool, so you'd be cutting giant triangles out of it. So there's a variety of different ways you can use that to help move your candy. And so if I chose OK, so now we have that body, and we could then create a cylinder through the center. Let me create a new sketch. So why wasn't it able to create that sketch? All right, finish the sketch, extrude. Interesting. So I want to extrude. Oh, because I'm joining it. I want to use this as a new body. That's what was going on. And so since I created that as a separate new body, we're okay there now. So body 2 and body 3. So I want to subtract the 2. And let's see here, subtraction. I might have had to do this in the opposite order. Let me delete this and delete that. And let's see if I create that. Okay, so that worked. And if I edit this feature, center revolution height, new body, and instead of creating a separate new body, I can use this to cut an existing body, which is the cylinder. If you notice what I was working on in here on the bottom is I dragged the cylinder before the other coil. So I just dragged it into the orientation that I needed. And now with this coil, I'm going to change it from creating a separate new body into a cut situation. And now it cuts that coil. Makes sense? Did we follow that process? Or do I have to hit the undo and do a slow motion instant replay? It's hard to tell if I don't get feedback.
I got it.
Okay.
The good news being on here, I'm probably gonna forget anyways, but I'm gonna rewatch your video.
But yeah, I will. I need to post Monday's video also. But Monday's video, we didn't cover a ton of material. But today, with the fusion, we'll cover additional material.
I still can't get onto the 360. It's saying that I haven't verified an email.
Well, you want to. Well, inside your My.Sinclair login, you'll need to go to your mail client. So not inside eLearn, but inside the My.Sinclair mail client.
Mm-hmm.
And then inside there, you should have gotten an email from Autodesk, and you can also look in your junk mail to see if it showed up in the junk mail side.
I'll check again. I've been waiting on it for a week.
You can also call them, because that's another option. They actually do have, or you can chat with them, do a live chat through the student.autodesk.com area. Let me sign in and I can show you here. And I can share. New share. Where am I at? I'm here. I have too many windows open. All right, so we've got that done. So inside the Autodesk area, you can obviously do support.
Right.
And then under support, you can do customer service.
So maybe I've been doing it the wrong. Maybe I've been doing it the wrong way.
Because you want to go into the student education, autodesk.com/education is where you want to sign in at and download the software. Because if you're just going to Fusion 360, then what's happening is you're downloading the commercial version as opposed to the student version, which there isn't anything different between the two except your login information. And so if you go to support, you can do the virtual support by asking, and they also have chat. Right now, chat's not available because they're based on the Pacific time zone. And then you can explain what your problem is in detail and submit it, and then they'll get back with you.
This happened when I was trying to do Inventor too.
Yeah, but that happens. The other thing is make sure, when you do the free software side, and you select the individual license from Fusion under the education area, it should install it automatically and provide you your license information. So you can actually, if you're, if eligible users can request an extension of their education license, you can visit email support at the bottom, is another aspect. So down here will be email support. So you get it free for 30 days, but then, let's see here, support, product support. That's the general product support. I'd prefer you to go through the education product support, where we were before, because we're now in the Fusion side of the fence, and so it'd be better to go into, and Fusion might be totally a separate product from the community. You could also go into the community forums, and inside the community forums, thanks, they'll have Fusion 360 support also. All right, waiting for the forums. Come on.
Has your internet been any slower than normal lately?
No, not really. It's actually been pretty decent. So it's definitely on their end. My internet has been lickety split, so it's definitely, see, there it is. So you can then find Fusion 360, and inside the Fusion 360, interesting. We're waiting on that. But anyways, that would be another way to get additional assistance is through the forum. Because again, you're outside of the student community in that forum. So yeah, I'd contact them for support.
Or
Definitely on the Fusion stuff, because you do want a copy of the Fusion, because that is going to be a very interesting tool
just
as you go forward.
showing us how to do that coil is so easy.
It is. It's actually pretty easy. It's the same process if you think about it. If you want to cut the coil like you do with Inventor, you can do the same thing, where you create the cylinder, create the coil. But the coil process is simpler overall. Let me flip back to my share screen here, back to Fusion. All right, we're now back on Fusion again. So what we've covered so far in Fusion is how to create the basic models, which again, you've all learned how to do it through Inventor. In terms of tools, we haven't talked about lofting and sweeping within Fusion, but we can do that here in a minute. And the process of sweeping and lofting work exactly the same way like in Inventor. And you probably want to use a loft in your design for your candy dispenser, because it makes it easier to create the products. One thing that Fusion has that Inventor doesn't is webs. So if you needed to put a support web in a product, it can put that support webbing in a product for that 3D printing aspect or injection molding aspect. So if you were to either 3D print or injection mold, if you needed a structure under an object, it's an interesting tool to be able to create a web. So we don't have that in Inventor. We can create a sketch and extrude a object to a surface, which in essence works the same way as a web, but this is a tool that accomplishes that task. So that's under the creation side. And they also have the ability to create a freeform tool. And I should probably demonstrate that also. I'm not really good at freeform bodies, but it is, it's kind of like working with molding clay, kind of a thing. And so as an artist, you could do some pretty fun and amazing things with the freeform tools. All right, so let's do this. Let's create a new product, new design. I said that I talk about the loft initially, and the idea is that we'll create a sketch. And so, this could be anything, but let's say I'm going to go rectangular or a square, and we'll make these 3 inches by 2 inches. And so this particular sketch is actually on the 0, 0 plane. I'm going to create a new plane based on that same location of the base plane, but I want it to be above. So I want to create a new plane above that base plane. And so we want to go, we'll say 4.50 inches above. So again, just like Inventor, we just created a new work plane 4.5 inches above, and we'll create a sketch on that work plane. So now, if you take a look at this from the right-hand side, what I'm doing is I'm working above. See, the plane is above the original object. And so I'm now let's see here. That just messed up. Let me undo. There we go. So I'm going to create a sketch on that work surface. On that work surface, I'm going to create a circle, but I'll create a circle based on more or less the center of that rectangle, and I'll make it smaller. And so I'll finish that sketch. So now I've got a circle here and the rectangle here. They're, what did I set, 3.5 inches apart. And so just like in Inventor, we can use the Loft tool to go from one surface to another surface. I just picked the point. That was incorrect. So I went from a sharp profile, so I want to cancel that. I actually want to pick the surface. So you can see how I picked the point and it went from the rectangle to the single point, but I actually wanted to go to rectangle to the circle. And so if you're thinking about a hopper design, this is a way to create a hopper. So your candy flows from a larger surface down to a smaller opening. But right now, this is a new body. It's not hollow inside. So we do have the ability to shell out the insides like we did before. And so if we want to create the bottom, both sides are open. When we shell out, we pick both sides, and then we have to give it a thickness. So if we want the wall thickness to be 1/8 of an inch, now the wall thickness is 1/8 of an inch all the way around the part. And so this is no different than the Inventor tools. Okay, this particular process is absolutely no different. It's just following the same guidelines as we did. Now we did shell to the inside, so the outside diameter is exactly the same diameter as we started with. We made the wall thickness move to the inside. I could do halfway between inside outside, or we can do it fully outside. But usually working with our standard outside dimensions, we always offset to the inside. So now that I have, my object, I can then select the object, change the appearance of the object, or change the material of the object. And so we want a glass or clear plastic material. And so we can do acrylic clear on this. And with that being acrylic clear, yes, it's kind of hard to see, but when it gets rendered, we can actually have a clear hopper with things inside, is one way to think about that. Let's see here. They don't have that. I think if we went to glass, we could do colored glass, where it would have a little bit of a tint to it, so you could still see the product inside and so forth. So again, different things that you can do with that particular loft capability. And so you can take any two shapes. So I just did a rectangle, but we could easily do a different object itself. So in that orientation, we could say, I'm going to go with a different direction just so it makes it easier for us to work with. So I could create my own shape. Okay, that's going to be a unique shape. And then I can say, from this shape, I want to create another work plane. I don't think I'm going to go 6 inches, but we'll go 4 inches off. And then I can produce a new sketch on that work plane. And then we can create another object. And so
every time you create a new work plane, I look away for a second. Can you show me how to do that again?
Looking away on a work plane. All right. Well, then we'll create a third work plane off of this object. So
You're just hitting construct.
I'm just hitting construct because that's where the work plane is.
Offset plane. Okay.
And then I just grab the arrow and move it.
Well, that's way easier than Inventor.
It is easy. And then I put a sketch on that work plane, just like we've done before. And we can actually draw a circle on this one. So now I've got 3 objects that it's going to loft to, and you can keep going. And so if I use the Loft tool, here's my base to my middle to my circle. And so now it creates the transitions between each one. And then you can use the shell command and shell the top and the bottom, because of course I want both surfaces to be open. And the last dimension we used was 1/8 of an inch. And so you can see how this actually creates a shell. And here's the thing. You don't get many modeling errors. Like in Inventor, you get some modeling errors at times where it says that it can't do things. In Fusion, it's rare to get a modeling error, an error where it says, oh, you really messed up and you can't do that. Unless you fold something upon itself, that's going to happen regardless. But as you can see, we went from a large object to a small object to a larger object and did not have an issue. And by the way, if we wanted to, we could go back and edit any particular sketches, finish the sketch, and it updates it and gives us a live update with it. So again, that bottom bar across the bottom gives us that flexibility to go back and edit and modify any of the components that we're working with. So that's lofting. And lofting, you're going to probably utilize lofting in your candy dispenser, whether it's to create a chute for your candy to slide down. You could use the coil and create a chute for the candy to follow. There's a lot of different things you can do with the with that ability of the lofting. But
I got a question
sweeping,
for you.
go ahead.
I was wanting to use some gears, and I know that you gave us the spur gear. Is it that difficult to make a gear teeth, or can you make a gear? Do you have to create each individual tooth, or can you do like a circular pattern and have the teeth wrap around something?
Let me see here. I haven't created gears yet in Fusion. There is a gear designer inside Inventor, and I have not been to the Fusion App Store to see if I can find a gear designer yet. Let me go into Fusion App Store. Oh, yeah. So the Fusion App Store, let me switch my share to Fusion 360 plugins.
Nope.
Okay, so there you go. So there's the Fusion App Store. And so you can install different tools inside the Fusion App Store. And I'm all about free. And so there's different capabilities with the Fusion app. So if we search for gear, okay, there's FM gears, which are free, helical gear generator, rack gear generator. That's a Mac operating system one. Bevel gear, spur gear creator, helical gear plus, which looks like you can create rack, spur, and worm gears. So the helical gears plus looks like the one that you'd want to use. By the way, the rack gear for $1.99. I wouldn't spend any money on it, to be honest with you. There's enough ones out there. So the one that has the most downloads, helical gears, herringbone gear, spur gear creator. These are the ones that have the most. But that again, $1.99. FM gears. So if you wanted to create gears within Fusion, that would be the way that I would go, is use one of the free apps to develop your gears inside Fusion. there seems to be quite a few options to look at different gear generators. Worm mesh gear. This is perfect if you're going to do a, but it's $20. I'm not going to spend any money. I'll be doing free apps only. So yeah, there's enough free apps. Like the Helical Gear Plus looks like it's an interesting thing for free. Best rating. Yeah, FM Gears and Helical Gear Plus would be the ones inside Fusion that I would download. They got a couple of reviews on each. So there's nothing built in directly to do gears within Fusion. And the way I got there was under the design, I picked the Tools tab up top. And so under Tools, there's an option for add-ins. You'll also notice that there's now an option for 3D printing built inside Fusion 360. And so I can set up my custom 3D printer that I may have, and then it'll actually output directly to that 3D printer. The file STL will be designed for that particular 3D printer that I input. So that's one of the newest things that they just added to Fusion was this new Make button to do the 3D printing capabilities. We'll click on it and see what happens here. And let me flip my share back over to Fusion. Boom. So now, yeah, I'm going through the make. I hit the make button up top. And so now you can see how it's created a mesh of my objects. Okay, and so it's basically meshed the objects or created a bunch of triangles so it knows how to create it. And it can send it to the 3D print utility, and Cura is the one that I use. That's the one that I use that is a generic 3D printing capability. So remember in class we were using the Stratasys print utilities on the Stratasys machines. Well, Cura is the 3D print utility that is used by most of the smaller 3D printers. So I do not have a 3D printer at home. That would be kind of fun to have. But that is.
These are opportunities for us to be reminded.
Oh, okay. But it is a free 3D printing tool that will allow you to create and send 3D prints. So, but that is how the Make tool works. Other utilities, manage materials, compute all. Again, under tools, you can do measurements. You can do measurements between object distances. And so if we wanted to make sure what the distance was, it's 4.5. And that is along the axis here. So it's 4.51 inches. So you have the ability to inspect and look for interferences, drafting analysis. So when you do injection moldings, everything has to have an angle on it, or else it's not going to come out of the mold. And so when you do injection molding and you're creating a part, every part has to have an angle to pop it out of the mold, otherwise known as a draft angle. And so this analyzes the draft analysis on the part, and I don't think will allow me to do draft analysis on either one of these. Accessibility, colorize an object based a certain area are accessible from a particular plane. So let's say, for example, you're creating a design and you have it fastening with screws, but you can't get to the surface easily to fasten the screws. So that's going to tell you, based on the direction that you're looking at or direction that you select, whether or not you have accessibility to surfaces. Color component cycling. Haven't tried this one yet. So, oh, interesting. So we can change, we can cycle a color on and off. Nice. Okay, so now we get the Easter pink color that it has cycled on and off. So that's under the Tools tab. Sheet metal, we haven't talked about sheet metal. That's going to be an upcoming discussion as part of our candy dispenser discussion. I usually go over a basic sheet metal part and how to fold it and how to unfold it. Typically, I'll do this in Inventor. I'll test it here in Fusion 360 also, but that'll be an upcoming presentation. Probably next week sounds like a good week to potentially do sheet metals. And I did promise you to go back to the ability to play with creating just a general form. So we'll play with that here in just a second. With that, under the modify tools that we haven't really talked about, they do a lot with faces. So you can grab faces, move faces, pull faces, splitting the bodies into multiple parts. We can do that in Inventor. And the idea behind that is if I need to create two halves of a mold, I can create the part, put a work plane down the middle, and then use the split capability. So I make a copy of the part, split one half away, and then I split the other half away. Or I can split the object down the middle to create two separate parts, otherwise known as the split body. And so I can split a body into two separate components. So let's see if I can do that. So if I'm going to construct a plane, so if I do an axis through a cylinder, it's not going to allow me to do it because it's not a full cylinder, but I need to produce a plane. Let's see here. Axis through a cylinder, cone, or torus. Since that's been extruded, it's not considered a cylinder. Let's try this, plane through two edges. So if we go here and here, it sent the plane through the two edges on the bottom. Okay, so it did exactly what it did. And we want a plane through, I want it mid-plane. But if I go from here to the bottom, it's going to cut it. Now that's going to be interesting. So if I do mid-plane between these two surfaces, all right, so it created a plane through the middle. So I created a plane through the middle of this part here. And I just want to make sure that I'm sharing. Yep. All right. Just want to make sure that I'm still sharing my Fusion. So now I'm going to take and split this part into two. And so under modify, split body. Remember, we have bodies and components. Components are used for 3D assembly. Bodies are used to create objects. And so if we want to split the body, I want to pick the body to split, which is the object. The splitting tool is going to be the plane. So it's going to split the body at that plane. And so now it's split, and you can see how it's now split it into separate surfaces, or actually separate bodies. And so now I should have one body on the top, and I should have another body. So that is taking one body there, and there's body number one. There you go, body one and body three. So it's now split into two separate bodies. So what does that mean? Well, as you know, I can create bodies into components. So now I can actually assemble this as two separate objects so they can be split apart. So if you think about your designs, you could create an object and then split it into multiple pieces for assembly purposes and so forth. So if I split this body into multiple pieces, I can then produce a pin on one side and a hole on the other for alignment and that kind of thing. But you can see how you can utilize the split tool as an advantage. So you create the hopper, you want to split the hopper in half, so on and so forth. That there's all different capabilities of that operation. All right. Freeform. And we'll do another new design. We'll pick freeform here. So when I pick freeform, I have the ability to create objects like a box or a cylinder or a quad ball. And then I can grab, so I'm just going to create a box. So we'll start the box. And so I can then drag the box. And again, and this is free form, so I can drag the box and think of it. Is everybody familiar with, excuse me, familiar with the, oh, let's see, I guess you can call it slime now. You know, back in the old days, we had silly putty
Oh
that we
yeah.
played with.
You put on the newspaper and it transferred the picture onto it.
You used to be able to do that. I don't know if you can do that now because of the inks that they're using. I haven't tried that in a long time. But silly putty was one of the toys that were out. But now everybody plays with slime, and you can create your own slime and that kind of thing. So think of it in that way. It's just a object that you're able to drag and shape very easily. So now once I create a general body shape, I can then take and modify that body. So I can put holes in it, fill holes, I can pull, you know, so I can grab points and pull. Come here.
Oh.
I should be able to pull a point, so I can pull multiple vertices. Target selection, force selected. It's not working the way I expect. But I should be able to modify, pull. Huh. Okay. Insert points, insert edges. As you can tell, I don't play with this side of Fusion all that often, so I'm learning along with you. So if we want to crease or bevel, let's see here. So if I want to take and crease, uncrease, flatten. Interesting. So if I flatten that, see, there should be a way for me just to grab these points. So you can see that I'm flattening surfaces based on the points that I'm picking. And it's kind of hard to tell, but I am flattening the surfaces based on the points that I'm picking. And so control points. But there is a way for us to grab the control point and move them. I just haven't played with it enough to so there is the ability to modify and can insert points, fill holes, erase and fill, weld vertices, unweld vertices, crease. So if I wanted to create a crease, that was interesting. So you can see how I flattened that by creating it as a crease. So it's interesting. So again, there's a lot more to this side. And like I said, I just haven't gone through any of the tutorials yet on managing this. But if you want to create free-form shape objects, there's definitely, so if I want to pull type, surface points, control points. So if I grab control points, No, targets. Nope, it's going to be auto. So anyways, yeah. So this is the freeform tools, but I'm not sure exactly how to edit these freeform tools. Time to watch a video, I think. I can guarantee there's some YouTube videos out there that are on that. All right. That was kind of a bust. Sorry about that. I thought I could grab some freeform capabilities and just kind of edit them along with the objects. Let me undo this. So just kind of edit them and grab them and kind of play with it like silly putty. But apparently there is something that I am missing in the if I edit the form. No, see, no, this is popping up as something to work with. All right. Okay, so our next step here is to work on our candy dispensers and to get the dispensers developing. Any concept ideas that you're working with? I've seen Josh's concept. Does anybody else have any concepts they want to share on their candy dispenser sketches, things like that? We can definitely do it via the video camera, or we can share your screen to share your idea. However, you're going to have industrial espionage here because your other colleagues in the class will see your design. So they may go, oh, that's really cool. One thing that I didn't talk about yet, which I definitely need to, since this was a bust, let's not save this, is sweeps. So sweeps are similar to lofts, except sweeps follow a pathway. So let's go ahead and create a sketch. And I'm going to create a sketch that looks like this. Oops, I messed that up. Hang on, undo. And then I want to create this to be straight here. So we got a sketch, and let's go ahead and dimension this out. So it's got some 2 inches, 1 inch. That was bad. Let me go ahead and finish. Drag this out so it cleans up. And want to, well, height is fine. We can do 1 inch on the height. 0.20 here. 0.20 there. And then we want to dimension, ouch. Let's see here. We can do angles or we can do positions. And so if this is 1 inch and that's 2 inches, then that should be a 1/2 inch. And that locked everything up. So there's our sketch. Okay, that's going to be, overall height on this side isn't correct. So we need to do that as 1 inch also. All right, so there's our sketch that we're working with. And we'll finish that. Now we're going to do a sweep with this sketch. And what that means is that we're going to create a pathway for that sketch to follow. And so we're going to create a new sketch on a different plane, and that plane is perpendicular. So you can see that the current sketch is right here. It's a very faint line, but the sketch is here on that surface. And so if I tilt this just a little bit, you can see the original sketch. And so now I'm going to create what is known as a spline, which is a smoothed arc, more or less. I can still use lines and arcs. That'll work too. But I like using splines because they're a little bit smoother. So we're going to have it come out. And we're going to make this pretty sweeping. And the big thing you have to remember with this is that you do not want this to intersect itself. What that means is that this particular shape, you need to be large enough to where this edge is not going to touch itself as it goes through this curve. So we finish the sketch and we're going to create a sweep. And so here's our product profile. The pathway is here. And you can see that we've created a swept path. And so it took that shape and said, all right, we're going to follow that path to create your dispenser chute. So as the candy comes down, it will follow this path and it dispenses it. Could you do this in 3D? Yes, you can do this in 3D. Okay. It is easiest to do this in a two-dimensional environment, obviously, but you can actually do this in a three-dimensional environment also, with the ability to take and move 3D sketches and paths and so forth. So yeah, your path, you can still edit your path. Again, let's cancel this, but I can go back and edit my sketch, my path on my sketch. And let's see here. And let's see if we do that. So you notice that it's still only in a two-dimensional plane because I'm not working in a three-dimensional environment. I picked a sketch plane that is a two-dimensional sketch plane. However, I can continue. Oh, wow, that's going to create something unique. But you can see that you can take and stretch this. And this is where the spline command works the best because you're able to grab the data points and create a pathway that you can. And let's go back and do another sweep. Select the path and be aware that I'm actually having to go over to the dialog box and pick the path or pick the object. And so you can see how that creates a really cool tray. Almost looks like a log flume ride. If you're thinking about Kings Island or something like that, you can create your own log flume ride, but only in a two-dimensional sense until you get a three-dimensional sketch plane. And right now we're only working with two-dimensional sketch planes in that environment. Cool. Was that good? Any questions on lofts or sweeps? We'll kind of not talk about the free form stuff, but lofts and sweeps. Man.
I think I got it.
Okay. All right. Well, that's pretty much what I wanted to share today, because every day I wanted to kind of give you some more tools that you can use and ideas on your candy design and some of the features that you can put in within the candy design environment. So again, different options, different capabilities. The loft and the sweep works exactly the same as it does in Inventor. So Inventor, you have to create the multiple planes, perpendicular surfaces. That makes no difference. Both work really well. All right, well, we can take a break. I'll be here for the next hour and 20 to answer questions. I would suggest that you work on your candy dispensers in case you run into a problem as you go forward. I did grade everything in the class, so everything is updated, graded wise. I've been going through my other classes now. Jason, you indicated that you had a
AutoCAD.
AutoCAD question too. So let's take a break. We'll come back in about 10 minutes and we'll solve an AutoCAD problem. How's that?
Sounds good.
All right. Let me go ahead and stop my share. First, stop my video. So I'm going to create a really simple angle bracket, and or I can even create just a, I know what I'll do is we'll create a shape. Thanks for reminding me to share my screen with you so you can see it. So all I did was create a shape. We're going to create an edge. So we'll make this so this particular shape is 3 inches long on one side, 2 3/4 inches long on the other side, and 1/4 inch. And if we want to put an angle in here, 145. Wow, it will allow me to do a 145-degree angle. And so now it's fully constrained. So I'll let you catch up here for a second. Okay, now that you've got that created, we're going to go ahead and finish the sketch and extrude it. And we'll grab and pull this up, and we'll set this at 1 inch. And so our object is going to be 1 inch tall. And what we're going to do is we're going to put 2 holes in this object. And so we'll put a sketch on the short side of the object. And we can either create it as 2 points and then use the hole command, or we can create 2 circles. In this case, it makes no difference. So just for simplicity, we're going to create 2 circles, and along the center line, we'll put 2 circles. Distance of the circles from the back edge to the first circle, we'll do about a 1/2 inch. And from the first circle to the second circle, we'll do about 3/4 of an inch. Let me undo that last dimension because that did not work out as well as I expected. There we go. So between the 2 holes, we'll do 0.75. And the holes themselves, we'll set those up as 0.125 because, again, we only have a 1 inch diameter or 1 inch sized object. So you have 2 1/8 inch holes. First one's a 1/2 inch from the back. Second one's 3/4 inches from the other hole. And when we're finished, we'll we'll work on the next step. So once I have the two holes and positioned, we're going to go ahead and finish. We'll extrude the two holes, but we'll cut them. So we'll pick the two objects, we'll drag them through, and we'll just say the extent is all the way through, and it should automatically cut the holes through that because the operation is a cut scenario. So now we have two holes in our object. So this is the object we'll put our stress analysis on. And what we'll do is we'll put we'll make it a material of mild steel, and we're going to put like a 10-pound force here on the end, and we'll fix the holes because that's where it gets fastened onto. All right, so now that we have this, I'm going to go ahead and hit save so I can save the object. And so we'll just call this scraper because it looks kind of like a scraper. We'll call it scraper stress. And now that I've saved it, I have to go from design into simulation. So I have to go from the design tab to the simulation tab. And I'm going to do a static stress analysis on the simulation of the object. So we're going to do a static stress, and we're going to create the study. So you can see that it brings in the model that we just previously saved. And we'll go ahead and minimize here the quick setup. As we work with this study, we can just walk across the top options. The first thing that we're going to do is apply a material to the object. So we'll pick materials. And right now, the simulation model, we don't know what the material is, but we do want to override it and set up it as a mild steel. And steel mild. And we'll choose OK. So it's steel, comma, mild will be our material that we're going to apply to our object. So now the object is a mild steel. We then have to add our constraints. And so if we think about that, the longer side is the top and the short side is the bottom, or we're going to add constraints. And so the constraints we're going to add are the actual hole itself. So the hole is going to be a constraint, but then, and we'll choose OK on just those two holes. So you can't do all the constraints on one setting. We have to set the hole constraints first, choose OK, and then we'll come back and put the edges of the holes as a constraint also. So I'll go back to constraint, and this time I'm going to pick just the edge of the hole as a constraint. Why both? Both locations are required because as we fasten this down, the fastener will go through the hole. Okay, and so theoretically it's fastening the bottom edge of the hole, which is where the circle is. If we were to glue it down or to have this against the surface that we feel that it's not going to move at all, then we can pick the bottom surface. But in this case, just the holes are what we're going to select as our criteria for analysis. Now that we've got our fixed constraints selected, and it took two separate commands, we're going to rotate this around a little bit, and we're going to select this front edge to put our force on. And so we've got different types of forces. In this case, we're going to do a structural load of a force, and the structural load will be based on this front edge. So in structural loads, okay, you've got the dialog box, and typically when you're dealing with structural loads, you're dealing in newtons. However, our problems, that we posed is actually in pounds. And so we need to change our units from newtons, which is the most common units that you're going to use, which is the metric unit of measurement of force. But we're going to change it to pounds because we said that we want to use 10 pounds of force. Now, the direction of the orientation is the other aspect. And so that's going to require us to look at our view cube here to see what XYZ looks like. So if we're looking straight down at the top, okay, we want the force to be in the X direction. So I want to say 10 pounds in the X direction. So if the arrow's pointing in the right in the correct direction, that's great. If it isn't, then I'll have to use negative 10 pounds to set that force up. In this case, it looks like the force is pointing in the correct direction, straight down in the middle of our object. So the X direction, again, looking at the view cube, it tells us where the XYZ orientation is that we're looking at. And so with the 10-pound structural load, we'll choose OK. So now we've constrained it, we've added the load, we're now ready to do a pre-check to make sure that we don't have any issues with our design. And it says constraints, same entity like another one. Those are just warnings, we should be okay. And then we'll hit the solve button. And so now it's going to go and we'll solve our study. And it may take a couple of minutes. It depends on how many simulations are being run across the world. So it may take a second to do our simulation run because it schedules them. And there we go. So now my scraper is complete. It did an analysis. And so our deformation is what we're looking for. Now it comes up as safety factor initially, okay? It comes up as safety factor. And so what we're looking for is the displacement. And so our displacement is 0.01474. And so that is our total distance that the tip moved being mild steel and applying 10 pounds of force. So it didn't move much. Moved just a little bit more than 1/100th of an inch, about a 100th and a half. So that gives you a general rundown, Anya, of how to create the force study in Fusion. Were you successful?
Yes, I'm almost there. I just need to finish get to the solution. Were you able to hear me?
So you can always go back and change the units if you need to. So you can close the results. So what you can do is go back on the structure here and go back to load and apply your load again, or edit the load. So if you go under the loads and we apply a force, and again, you have to scroll down to the bottom and change it from newtons to pound forces. And I only applied 10 pounds of force on the end. But you have to do that over in the browser and dig down into the loads.